Didn't expect to make mistakes. Thanks for catching that. The minor axis was 2 and another 2, so it's 4. Now, the focus points. This is where c squared equals a squared minus b squared comes in, because I need to know how far to move away from the center. And the focus point is always on the same line as the major axis, as the vertices. So I always know to go towards those vertex points. So c squared is equal to 36 minus 4. C squared is equal to 32. So c is approximately, well, 36 is 6 squared. 25 is 5 squared. I'm going to estimate that's about 5.6 or so. Use my calculator to get a little bit closer if I need to. The square root of 32. 5.65 rounds to 5.7, so 5.7. Approximately 5.7. So if I'm at -1 and I subtract 5.7, it's going to be at -6.7. So it's actually going to be very close there. And so it's negative, the x is going to be -6.7 and still 2, because we're still on the y line, y equals 2 line. And over here, now I'm going to be a little more careful because I've got to go up to 0. So I'm going to go 1, 2, 3, 4, 5, and a little bit more. And so it's 1, 2, 3, 4.7. So it's 4.7 and 2. So those are approximations. It would be perfectly okay, and in some places they want exact answers. I don't fear, you can do that with that. But you're going to get to some college courses in the future where some professors might be really picky and say only exact answers. So that means the exact answers would be, I'm at -1 minus square root of 32, because c is equal to the square root of 32. So I could have put 1 minus the square root of, or -1 minus the square root of 32 and 2, and -1 plus the square root of 32 and 2. So those two answers are acceptable, or these two answers are acceptable. I'm okay with either. All right. These are considered exact because you have not had to round off those numbers yet. Here, they're not exact, they're only approximations. I give you permission to do approximations for this, because it makes a lot more sense putting it on a graph in my opinion. Okay. But you can do it either way to get it right. So think about the parts of this. You can, from this, get the center and the A and the B, or the minor and major axis, and which way to go. And then from graphing it, you can then get the vertices and the lengths of the axes, and then you use this little formula to get focus points. Let's do it for a second one. That means I need another one of these. There at the back. And on the second one, now that's where I'm going to do this one. Y plus 1 squared over 36 plus x minus 2 squared over 4 is equal to 1. Sort of the same idea, even some of the same numbers, except now that's changed. So that means that when we get the center, -1 and +2, oops, wait a minute, it's not. See, I have to, it's a good thing I do generally stop and double think about it. Okay? Because we're used to just taking the first one as the H and the second one as the K. The one with the Y is the K. So that means the -1 goes second, goes for the Y. So that's the K. And then the H is here. Some of you probably caught that immediately and you realized it and wouldn't have made the mistake that I just did. I caught myself fast enough that I can do it right. But watch for things like that, that sometimes it's opposite, because the one with the Y is the K, and we always write coordinate points anyway as X and Y, so I can put the Y there. So the center is a +2 and a -1, +2 and -1. So there's my center. Again, it looks like the A is 6, and the B is 2, but now the 36, the larger number, is underneath the Y, so that means we're parallel to the Y-axis. So now I go up 6. 1, 2, 3, 4, 5, 6. So that's one vertex point. 1, 2, 3, 4, 5, 6. And here's the other one. And if the B is 2, I can just go 2 that way and 2 this way, and draw myself a decent ellipse. Oh. Well, sort of misshapen, but I'll have to accept this. So if you draw worse, if you draw as bad as me, you don't have to worry about losing points because you know that's the way I draw. If you draw better than me, I'm perfectly happy with that. Okay. But now I know enough information. The vertex point, 1, 2, 3, 4, 5. So the vertices are at 5, and still the, oh no, wait a minute, the x-axis. The x-axis has stayed at 2. It's the y going up to 5 that's changed. And then down here, 1, 2, 3, 4, 5, 6, 7. So we're at 2 and -7. Right, so watch out for that switching when you go the other way like that. Okay, focus points I'll come back to in a moment, but I'll be using this, so I'll set it up for it. The length of the major axis is again 12 and the minor axis is 4. Now here, c squared is 36. Oh, wait a minute, this seems pretty familiar again. Square root of 32, or 5.7, about approximately. So that means it's somewhere about here and somewhere about here. So I can say 2 and 4.7, or 2 and -6.7. Okay, so, or I could say 2 and whoops, 2 and -1 minus root 32, or 2 and -1 plus root 32. Same concept as the other one. Doesn't matter really what the numbers here are, you know which way to go or how to use them now. Okay. So now let's take some information. Here's where I think I'm going to just reverse one of the things. Let's say I told you some information. I have a problem like this one. Yeah, I do. Endpoints of the major axis are 2, 3, 2, -5. Endpoints of the minor axis are 1, -1, 3, -1. I'm going to give you that information and tell you to write the standard form. Standard form of the ellipse. Well, some of you can look at this and figure out where the center is pretty quickly, and some of you can figure out from that what the A and the B are and make the equation without any trouble. Me, I always graph these. I don't trust myself enough. I will always graph them and look at them. So I'm going to do that here. And you don't have to, but I'll tell you, it can really help, especially if you're not quite sure. So I'm going to graph 1, 2, 3, 4, 5, 1, 2, 3, 4. I'll go down, up and down 5 here on both. 1, 2, 3, 4, 5. So 2 and 3 is here. 2 and -5 is here. Aha, and that's the major axis, so that's going up and down here. 1 and -1, and 3 and -1 is here. So I see that the center is at 2 and -1. I could have gotten that from here, because I noticed for the major axis, the h value is the same. And for the minor axis, the y value is the same. So the one repeated here and the one repeated here are your center points, or your center h and k. So you could have gotten it just from recognizing that, but by drawing it, I really confirm it, and I feel really confident now that that's the center of the ellipse, especially since I can draw it there. Because I have enough information to draw it there. I didn't need to draw it though, I don't need that, I just need standard form. But now I know the center, and I know the A because of 1, 2, 3, 4, that's a distance of 4, and this is a distance of 1. So that means A squared is 16 and B squared is 1, and I have everything I need. X, now I'm going to do X minus 2 squared over, got a problem. Not a problem, but, actually let me write this, and then it's X plus 1 squared as equal to 1. But I have to put the a squared underneath the one that I'm paralleling the axis for. So the 16 goes here, and the 1 has to go here. And now I need to rewrite it, because although this is legal, I want you to do it the way everybody else does it everywhere that ellipses are done, which means the one with the a squared has to go first. Even though it's plus and it really doesn't matter, I just want you to get that habit of convention. When you do hyperbola, it won't matter because one's negative, so you have no choice whatsoever. So I would rewrite it to this. And there it is. Get my plus and my minus over there. So do it that way for convention's sake, because otherwise your college professors and classmates will think you're really weird for not doing it right, you know, and sometimes pick on you for it. You know, as far as I guess mathematicians will pick on each other. Okay, so I could have given you something different. If I had instead said that the focus points, let me write the word focus. Say I gave you what the focus points were, and I did not give you the minor axis. If I gave you the focus points and not the minor axis, you wouldn't know what b squared was or what b is. But you could then find the distance from the focus point to the center, and you would do c squared equals a squared minus b squared. And you could fill in that, and you could fill in that, and figure out what the b was, and then you'd have your b for the equation. Okay, so anything I give you, figure out from that how to get the other things, and this is going to help you with the focus points and the, here we didn't even need the focus points, but if I gave you the focus point instead of one of these two, you could use this to get the other one, and then you're set to go. All right, now let's do an equation. Okay. Good, we have enough time to do this one, and then hyperbola has a lot of similarities to it. So please write this equation, x squared, this is still 8.84, x squared plus 9y squared plus 2x minus 36y plus 1 equals 0. So what we're going to do is put it into the standard form, so it's going to end up looking like this, with either the y or the x first. We'll find out when we get to the end. Okay? So we have to figure that out. So what we're going to do is complete the square. Well, we're going to complete it for the x's, and we're going to complete it for the y's, so we have to move it around and put it in that order. So watch what I do here. X squared plus 2x, and I'll leave some space, plus 9y squared minus 36y is equal to a negative 1. I did three things. I grouped the x's, I grouped the y's, and I took the constant number and I moved it to the other side of the equation. So think about that part as well. So it's three things that I did. Did three things. X's, y's, and moving the constant. Now I'm set up to put in here c equals b over 2 squared. 2 over 2 is 1, 1 squared is 1, so I'm going to add 1 there. If I add 1 here, it's the other side of the equation, I add 1 here. This is different from the parabola. Remember, on the parabola, we worked only on one side. You add something and you subtract it to keep it even. For the circle and the ellipse and the hyperbola, you don't do that. You have two sides of the equation. So you add or subtract on one side, you do the same adding or subtracting on the other side. So remember that difference. So completing the square with the parabola has a little bit of a difference than it does for the center, for the circle, for the ellipse and hyperbola. Circle, ellipse, hyperbola, all done just like this. Okay? You just come out with something different in each case. Right? But make sure you remember that difference. Here we're working on both sides. For the parabola, you don't work on both sides. You add and subtract to keep it even. But here we're working on both sides. For this one, oops, I got a problem. I cannot complete the square if there's a coefficient for the y squared. Can't do it. So I have to take the 9 out. Y squared minus 4y. So now I can complete the square for this. And so negative 4 over 2 squared is negative 2 squared, which is 4. So I'm going to add 4 here. but I'm not adding 4 here. This is not really a 4. What is it? How much?
36.
It's a 36. Because of that 9 out here, it's a 36 that I'm putting in here. It's not really a 4. So if I'm adding 36 on this side, I'm going to add 36 on this side. So I have x squared plus 2x plus 1 plus 9, y squared minus 4y plus 4 equals 36, because minus 1 and plus 1 cancel. For many of you, you see what you did here, and you probably don't even need to rewrite it here. You can immediately go to x plus 1 squared plus 9, y minus 2 squared. Half of the 2 and same sign, half of the negative 4, same sign, is equal to 36. Almost there. So now we need this to be a 1. So I'm dividing by 36, dividing by 36, dividing by 36. X plus 1 squared over 36 plus y minus 2 squared over 4 is equal to 1. Should look familiar because we graphed that. First graph we did, I think, was this one. So this was the equation. This was the equation of that graph that now is changed into a formula or a method where now you can get the information out in order to graph it. Because now we can get the h and the k, -1 and +2. And we have A is 6 and B is 2, and you can graph that and you're good to go. Any questions about doing this for an ellipse? Okay. It's little details. Let's think about the parts of it before we go on to hyperbola there. So first thing I did was just set it up and organize it. Now it's easier when I set it up and organize it. Second thing I did was I did the correct C that I needed to then make the complete the squares. But sort of 2, this would be 2 and this is like 2A, is I had to take out the 9 from that. So it's sort of like part of it is going to be to take out a common factor if it's necessary. It wasn't necessary for this one, it was necessary for this one. So you're watching out for that, okay? And then sort of 2B over here is doing the both sides part as you find the figures. And then the third step is to make that, and the fourth step is to divide so you get a 1 over here, and then it forces you to have 36 and 40. If this one had been the 36 and that had been the 4, then I would have rewritten it again and switched those.